So today is the last lesson on simultaneous equations. We've done really well with the algebra side of things, but now we need to have a look at interpreting worded situations into these equations. So here's an example. So write this statement down. The sum of Andrew and Brenda's ages is 141. The difference between their ages is 5. Andrew is older than Brenda. And we want to know, how old are Andrew and Brenda? So we may be able to work this out with a bit of trial and error. However, that's not what the examiners are going to want. They're going to want to see us be able to take a worded situation and put it into an algebraic form. Okay, and if we do that with these sentences, we're going to find that they're going to give us a couple of simultaneous equations to solve. So let's start off by assigning each one a letter. So let's say Andrew, we're going to represent him with the letter A, makes sense, and Brenda will represent with the letter B. So let's now take each one of these statements and write it in algebraic terms. So let's start with this first one. The sum of Andrew and Brenda's ages is 141. So think about how you'd write that algebraically. Hopefully we've remembered that sum means add. So the sum of Andrew and Brenda's, or A plus B, equals 141. The difference between their ages is 5. So how would you write that algebraically? Okay, A minus B, that's difference, equals 5, the difference between the two. And we know Andrew is older than Brenda. That information we can use at a later date. But that basically is included in this sentence here. So now we've got two simultaneous equations. Let's have a look at them, and so we can just solve them using the skills we've been learning. So are any of the coefficients the same? Actually, yes, they are. They're the same for A and they're the same for B. So I can either try and eliminate A or I can try and eliminate B. I'm going to eliminate B because I can see quite easily that the signs are different. So if I add them, and I find adding easier than subtracting, if I add these two equations, the B's are going to disappear. So I'm going to add equation 1 and equation 2. And I'll get A plus A is 2A. B add minus B, well, they cancel each other out, that's the point. And 141 add 5 is 146. So therefore A is 73. I'm going to put that back into equation 1 to work out. So that's Andrew's age. Don't forget to think about interpreting. That's Andrew's age. And I'll put it into equation 1 to work out what Brenda's age is. So Andrew's age plus Brenda's age equals 141. So Brenda's age equals 68. I'm just going to double check that in terms of the context of this question. So I'm saying that Andrew is 73 and Brenda's 68. The sum of their ages, what's that? It is 141, so that's correct. The difference between their ages is 5, 73 to 68, that's 5. And Andrew is indeed older than Brenda. So I know that that is the correct answer. Another example now. At a festival, 9,624 tickets were sold. So make sure you're writing this down. Child tickets cost £45 each, and adult tickets cost £80 each. And we know that the total revenue from ticket sales was £731,525. And the question here, how many of each type of ticket was sold? So how many children's tickets and how many adult tickets were there? So first of all, see if you can just put together the algebraic statements yourself. Okay, so let's say C, that's going to represent our children's tickets, or C is a child, and A is an adult. You know what, I'm just going to use uppercase, that's absolutely fine to use. Right, so 9,624 tickets were sold in total. So I know the number of adult tickets plus the number of child tickets has to equal 9,624. I also know that, so how would I work out this revenue? How would I work out the amount of money I'm going to get? Well, I would take the number of child tickets and times it by 45, because that would tell me how much money I get from the children's tickets, and I would do £80 for every adult ticket, and that should give me this value. And straight away there, we've got two simultaneous equations to solve. Yes, the numbers are bigger than we're used to, but we're still going to follow exactly the same techniques. So first of all, we see, look, are any of the coefficients of the variables the same? No. There is 1a in the first one and there's 1a in the first one and 80a in the second one. See, the variables, the coefficients are different as well. So I'm going to have to do some multiplying to get one of the coefficients the same. So if I've got equation 1 and equation 2, well, hopefully you can see if I multiply equation 1 by 45, then that's going to give me 45c, and that will make the coefficient of c the same. So I have 45c plus 45a equals 9624 times 45 is 433,080. If I can just highlight at this point here that when that first question, in equation 1, it's a plus c. All right, when I've done this multiplying, I've written it c plus a. The reason I've done that is so that my c's line up and my a's line up, and it's just a bit neater and it's a bit easier for me to see what's going on. Okay, so I've made the coefficients the same. The next step is, do I need to subtract them or add them? Well, I look at the coefficient that's the same, the signs are the same in front, the signs are the same, you subtract. Right, so 45c take away 45c is 0c. We eliminate c, that's the point. 80a take away 45a, I'm left with 35a. And finally, those two subtracted from one another is 298,445. And so divide both sides by 35. I work out the number of adult tickets sold were 8,527. And then I can just put that straight back into equation 1 to work out how many children's tickets were sold. So there were 8,527 adult tickets, and the number of children's tickets has to equal 9,624 together. So the number of children's tickets that were sold is 1097. And then I would put them back into, I would times this by 45, this by 80, and make sure it gives me this, which indeed it does. The last thing, and you don't need to write notes on this page, is just really reiterating the importance of checking your answers. And I'm going to keep going on about this, and every teacher will, because it is so important and it's such an easy way to find out if you've done something wrong. So here we've got two simultaneous equations, and a student works out that the answer is x equals 3 and y equals 4. Okay, so if I put these into here, that works. I might go, oh yeah, great, definitely, because 3 add 4 equals 7. Brilliant. However, if I put them back into this, well, 2 times 3 is 6, and 3 times 4 is 12. That equals 18 and not 19, so it doesn't work. Straight away there, I would know I've done something wrong. I need to go back, look at my working out. What have I done wrong? Fix those mistakes, and then I can check the answers and hopefully get it right the next time. But it's far more likely that we get our answers correct if we get into the habit of checking them as we go.